Hello, everyone. Welcome to Barnstable Town Hall. My name is Dan Santos. I am the Director of Public Works. And the purpose of tonight's meeting is, as you can see here, we're going to talk about PFAS in Hyannis, water supply, challenges and solutions. But more specifically, the town has hired a consultant, Jim Begley, and he's going to be really running most of the meeting and introducing the speakers. But Jim was hired by the town under a grant from the Department of Environmental Protection called a Technical Assistance Grant that the Department of Environmental Protection provides to communities, community groups, and municipalities to help them as a third party review the work of consultants that work on waste sites. And in this case, there's really two primary sites that are being evaluated in this Hyannis area relative to the Hyannis water system, and that is the former firefighter training area, Flint Rock Road off Mary Dunn Road in Barnstable Village, Hyannis, and then also the Barnstable Cape Cod Gateway Airport, formerly the Barnstable Municipal Airport. And so our consultant is going to introduce these other speakers that are going to give very brief overviews of their work, and then Jim is going to share with you all his review and his thoughts on the work that's been done by the county firefighter training area, because that our technical assistance grant is specific to that site. So our work, Jim is not looking at the airport specifically reviewing their work, but it's almost impossible not to consider all of this work because it's all in the same area and it's all the same groundwater. And so we need to work collaboratively with the various consultants and the various agencies that are working on this issue. So I wanted to mention that this meeting is being recorded, and the recording will be available on our Water Resources website via the Department of Public Works, Barnstable Department of Public Works. And also there are sign-up sheets. If you are, hopefully you'll sign up and we can get you any information that we have about this meeting and other events that we have regarding this subject matter. We'd be happy to share that with you. And then there's some cards on your seat. Jim's going to talk about that. We've been working on this problem since I've been here, which is about 13 years, and in earnest since about 2015, when the Department, the Environmental Protection Agency issued a health advisory for PFAS compounds. And we have been working diligently and seriously on this issue, primarily to make sure that you all are getting water that is free from PFAS. And we have successfully done that for the Hyannis water system. And that's been in place for a number of years, fully treated. And we want to make sure that you all know that, and that is reiterated as much as possible. Your water meets all regulatory standards, particularly for PFAS. It is all being treated. So I'm going to turn it over to Jim and let him go through the remainder of the meeting with you. Thanks for coming.
Thank you, Dan. Good evening. How's my level of sound here? Is it good for everybody? A little bit higher? Speak into the microphone. Okay. Thank you again for being here. So tonight we're going to cover a number of topics that are listed here. So we're going to talk about the PFAS contamination. We're going to talk about community concerns. We're going to talk about work that's being done by the Hyannis water system to maintain water quality, to produce clean water to send to residents in the Hyannis system. And then we're going to talk about sources of the PFAS contamination and where they are in their response actions. We'll also talk a bit about future directions and recommendations. Part of this is where we go from here. And we want to get your input on that. So there'll be some questions and answers at the end, but I'm also going to talk about getting ahead of myself. Let me first describe who we are going to have speak tonight. So, again, I'm Jim Begley. I'm with MT Environmental Restoration, and I'm working for the town, for specifically the Department of Public Works, overseeing and collecting information to support them in addressing this. Laurel Shader, to my left here, is going to talk about an update on the PFAS in your health study that she's working on. It's a CDC-funded program, which I'm sure many of you are familiar with already. Paul Razula is here from Barnstable County. He's the county asset manager. His consultant, John Paquin's here, and Dave Leone as well, who's the licensed site professional for the county and their site. And on my right is Brian Massa. He's here on behalf of the airport. He's with HRP Associates, and he'll be giving an update on the status of the Cape Cod Gateway Airport site. So we have the main source facilities represented here to provide information. I know most of you are familiar with what PFAS is, but just a quick summary. It's a synthetic compound. It's not naturally occurring. It's very persistent in the environment, and it's been used in a lot of materials, resulting in releases to the environment. It has health effects, and there are some very strict standards that have been developed to control the amount of PFAS that might be found in water. And the use of it in consumer products, and particularly firefighting foam, is very relevant here because firefighting foam is one of the major sources of PFAS contamination affecting the Hyannis water. But PFAS has had widespread use and resulted in widespread groundwater contamination, not only here, but in other locations. So it's a national problem, an international problem, really. And we're very much, I think, in Barnstable on the forefront of addressing this issue. With regard to community concerns, speak into the microphone. Oh, yes. Thank you. So we're here tonight also to hear your concerns, and part of what we'd like to do is, in addition to giving you an opportunity to ask questions and express concerns at the end, we've passed out some index cards that Kelly from the DPW will collect in about 20 minutes or so. So if you want to write down a specific concern that either you don't feel is being addressed or something that you want to reinforce, please do that. Keep it brief. We're going to try to summarize what they are and talk about them a little bit at the end. It's just give you another opportunity, and we'll have a record of what your concerns are. At this point, I'm going to give an overview of the Hyannis water system and information on the water quality that you're receiving now. So the Hyannis water system relies on groundwater in the area. There are multiple supply wells. This water supplies up to about 35,000 people in the summer when the population increases. And PFAS has been found in this water supply, and treatment systems have been installed. Starting in 2015 through 2018, all of the water supply wells have been put under treatment. These treatment systems are located near clusters of wells, and there are 3 major clusters that are being treated. While this water is being treated, the town is collecting water samples both on a monthly basis to monitor the treatment process, and also on a quarterly basis to assure water quality in the water that they're putting out. So as I said, there are multiple water supply wells. This map shows roughly where they are. They're shown in yellow here, and there's a cluster to the north, the Mary Dunn wells, and there's a treatment system at that location. The Mar wells are further to the south, just to the east of the airport. There's a treatment system in place there. And then there are 3 wells down at the southern portion of town, Straightway, Simmons Pond, and Hyannis Port. Those wells are treated actually individually, I think, at this point, but there's a new system going in that's going to treat them all together. So we have some results for these different locations to give you an idea of the water quality that you're receiving. First, I want to show an example of one of these treatment plants. This is the Mar Wells treatment facility, and Hans Kaiser, who is the DPW water supervisor. Hans is really the wizard behind the curtain, a real wizard who's keeping your water safe. He's operating this thing like a watch and managing the process so that you can get good water quality, and he's coordinating all the testing that's necessary. So looking at that system, the Mar wells, thank you. I have my own laptop here that I'm advancing and not doing that when I should. Sorry. The Mar wells have what's being analyzed and presented here is the PFAS-6 concentration. PFAS-6 is a grouping of PFAS compounds that the state of Massachusetts has identified as being a particular concern. The sum of those 6 compounds is used as a standard, 20 parts per trillion of these compounds, or nanograms per liter in the more technical term, is the state standard. The federal government has come out with maximum contaminant levels standards on the federal level as well recently. Some of those are as low as 4 parts per trillion for particular PFAS compounds. Some of those compounds are contained in the PFAS-6. I think there's 1 or 2 that are not. The state will likely be modifying their standard in light of the federal standard at some point in the future. What these data show is that the influent concentration coming into the Mar wells of PFAS-6 compounds is over 100 parts per trillion. And the effluent concentration from the treatment process, which is the treated water that's going out to the public, has concentrations that are all less than 1 in this case, 1 part per trillion or less. And where it shows a 0 on this data, it's a non-detect. So there's no detected PFAS in that sample. So here we're looking at sample dates in 2025. This is an example, but looking at historical data going back, the process has been similar. The concentrations coming in and the concentrations going out, very similar to this in the past. And this is very good water quality going out to the public. Mary Dunn wells is pretty much the same story. The Mary Dunn wells that are located to the north, in 2025, the influent concentrations of the raw water that's pumped from the ground has 70 to 111 parts per trillion or so, and the concentration going out to the water supply, the treated concentration, again, is all less than 1 part per trillion. And finally, looking at the wells that are located to the south, Straightway, Hyannis Port, Simmons Pond, what I'm presenting here is an average of the concentration from all those wells, as if they were being treated together. And again, the influent concentration, or the raw water being pumped from the aquifer, is close to 100 parts per trillion, and the concentrations going out are very low. There was one sample where the average was 2 parts per trillion. Everything else in 2024, which is when these data were collected, was non-detectable. No PFAS in the distributed water. I don't have 2025 data because these wells are not currently being used during the winter, and the first set of samples hasn't come back yet. So it's a good representative for that. And in the new treatment facility that'll come online, I expect the results will also be this good. So at this point, I'm going to turn it over to Laurel Schrader from the Silent Spring Institute, and she's going to talk about past exposure. What we just discussed was the quality of your water now. It's quite good. This is not the case in the past. And so there's concern about the health effects of that. And Laurel, I'll turn it over to you.
Can I have the thing to advance the slides? All right. Thanks so much. Good evening, everyone. Laurel Schrader. I'm a senior scientist at Silent Spring Institute. I appreciate the opportunity to be here tonight to share a brief update about the Massachusetts PFAS in Your Health study. I've worked at Silent Spring since 2009, and we were actually the first to find PFAS in the Hyannis water system back in 2010. And at that, testing from the EPA previously showed that levels of PFAS in some of the Hyannis wells were higher than any other water supply in Massachusetts. In all my talks, I always do mention the important work that the town has done to really step up and put in place treatment to filter out PFAS, as you just heard. So tonight, my goal is to share a brief update. I know there's a number of speakers, and happy to provide additional resources as well. So our study is part of a broader study that's being funded and coordinated by the Centers for Disease Control and Prevention, CDC, and ATSDR, which is the Agency for Toxic Substances and Disease Registry. And they're conducting what's called the multi-site PFAS health study. So the goal for the study is to learn more about how exposures to PFAS chemicals can affect people's health. And the vision is to fund research teams in different states who work with communities that have had a history of PFAS water contamination. So back in 2019, Silent Spring Institute applied to be part of this broader study, and we found out in September of 2019 that we were among the sites that were part of this multi-site effort, and you can see on the map the other sites that are part of this. So our study is called the Massachusetts PFAS in Your Health study, and I know a number of you have heard me speak about this a number of times. Our Massachusetts site has 2 communities. So one is based right here in Hyannis, again because of our longstanding work on Cape Cod, and because of the past highly elevated levels of PFAS in the drinking water here in Hyannis. Our other community is the town of Air, west of Boston, out on Route 2. This is where the former Fort Devens military base is based. Air experienced some contamination of their drinking water, but not at the same higher levels as we saw here in Hyannis. Again, in both communities, all of the municipal wells have been treated for a number of years. So what we're really thinking about is addressing some concerns about potential chronic long-term health effects and really learning what we can from these past exposures that we can't change. Our research team is partnering with other researchers from the Harvard School of Public Health and the Eastern Research Group. For our work here in Hyannis, we were really proud to partner closely with Cheryl Osimo, who's here tonight, Betty Ann Beavis, and others from the Massachusetts Breast Cancer Coalition. They were invaluable to our efforts to raise awareness about the study in the community and support recruitment for our study. in air, we worked with a local community group there called PACE. I won't go through all the lines of the timeline here, but we received funding again at the end of 2019. 2020, obviously, things slowed down quite a bit with the pandemic, and it wasn't until November of 2021 that we were able to kick off our enrollment of participants here in Hyannis. And we spent about 2 years recruiting people and conducting data collection here in Hyannis. By September 2023, our site and all the other sites in the multi-site study were required to wrap up our data collection and move into the data analysis phase. For those of you who took part in our study, all of our participants received a letter with the results of their PFAS blood tests and all the clinical blood tests that we conducted for people who were in the study. And then last June, we had a community meeting where we shared community level findings for Hyannis in comparison to air and to the general population. So I'll give a few highlights from those initial findings tonight and share a link if you would like to learn more. Just to give you a sense of the scope of the study, here in Hyannis, we recruited and enrolled nearly 400 adults and 41 children and adolescents to be part of our study. For our 2 sites combined, we had nearly 700 adults and about 90 children in our study. In case you're curious what goes into a study like this, for our participants, we had them come into our temporary clinic to provide a blood and urine sample. We did body measurements like height, weight, and blood pressure. We had our participants complete a questionnaire. We asked where they lived and worked over time. We asked about their water consumption patterns, whether they were someone who drank mostly bottled water versus filtered water versus unfiltered tap water. And we asked some questions about their health over time. For children and adolescents, we also conducted a series of neurobehavioral tests. Another part of our study is to try to go back in time and to estimate each participant's cumulative exposures over time. So we could have had 2 people come into our clinic in 2023 with similar levels of PFAS in their blood. Maybe one person had lived in Hyannis their whole life and drank unfiltered tap water, and someone else moved to the area more recently. And so we want to be able to distinguish those differences in cumulative longer-term exposures over time. So that's another component of our study. So I'll walk you through a couple of graphs that look like this. And again, if you're curious to learn more, I'll share a link for how you can learn a little bit more about the details of our initial findings. So again, this is sharing the median, so it's kind of the middle level value for participants in our study here in Hyannis, in the blue bars, in air in orange bars, and the gray bars are from a study that CDC conducts every couple of years of a representative sampling of people in the US to try to get a sense of the general US population. For those of you who've attended other PFAS talks, you likely have heard of PFAS and PFOA. Those are 2 of the PFAS most commonly found in the environment and people's bodies. And all 4 of these, PFAS, PFHXS, PFOA, and PFNA, are regulated both as part of the PFAS 6 that we just heard about and also at the federal level, at least for now. And so what I'm showing here, again, the median levels among our participants. So what I want to bring your attention to is the median level here in Hyannis for PFHXS. The median level was 3.5 times higher than the general population. This was not unexpected. PFHXS has what we call a really long half-life in the body, so it's difficult for our bodies to excrete. And this particular PFAS tends to be elevated in people who live in communities where the drinking water was contaminated by firefighting foam, so that's not unexpected. For PFOS, the level was not quite as highly elevated compared to the general population. It was about 33% higher. I do want to mention, because sometimes people hear of PFAS as forever chemicals, and that's because their chemical structures are extremely stable. And sometimes people think, oh, if they're forever chemicals, they will stay in my body forever. And I do want to let people know that for even these PFAS that do stay in our bodies for long amounts of time, we do know that if we cut off exposures, that the levels go down over time. That's CDC testing. They have some graphs. They've been following people in the US since 1999, and they have clearly shown that these PFAS, which actually are no longer manufactured in the US, are going down in the general population. So it's an important thing to know is when we address the contamination in the drinking water, that does mean that the levels in people's blood will go down over time. You might wonder why the air level is actually lower than the general U.S. population, and I think what that reflects is that the samples from the general U.S. population were collected in 2017 to 2020, whereas our samples came a few years later. Again, with that downward trend over time, we think that that just reflects the fact that the air samples were collected later. And when we tried to account for that general population decline, we found that the air levels were more similar to or slightly higher than the general population. The last thing I'll point out here, I'll just go back here, is that for PFOA and PFNA, which were not as highly elevated in the drinking water, we see that the blood levels are more similar between our two communities and the general population. So this is a very brief overview, and we had some other general findings that we shared last year right here in this room. If you would like to learn more, we have information about that on our website. You can scan that QR code for a link to the video recording from that meeting and also to the slides that we shared. In terms of what's next for the study, as I mentioned, we're trying to go back in time to recreate what used to be in the drinking water in Hyannis, and we're able, combining that information with what people told us about where they lived and their water consumption patterns, and plugging that into what's called a pharmacokinetic model. And so that allows us to estimate what their blood levels might have been over time. And again, that can tell us something about chronic longer-term exposures beyond what we can learn from just the snapshot that we received from the one-time blood sample. I am not an epidemiologist by training, so I have learned a lot about epidemiology over the past couple of years. And you might wonder, well, what have you been doing in the past time since you finished collecting data? And there are many stages to the data analysis. So for all the sites, there's nearly 6,000 adults and 700 children and thousands of data variables that we have for each one. So it's a massive undertaking to combine that data, to ensure consistency, and to divvy up the task of analyzing that data and looking at what we can learn about many different types of health effects. There's a paper, and just since you sent the request for slides last week, the first paper from the study actually just came out. I found out at the end of last week. That, again, is just based on the blood levels, but this new study provides a little bit more information about how our Massachusetts participants compare to the other 7 sites in the study. In terms of our site's work, we are analyzing the data from Massachusetts and from participants in the other 7 sites to look for links between PFAS and hypertension and blood pressure, and also metabolic syndrome. The data from our Massachusetts participants are also in that larger pool of data, and so there are other papers that are looking how PFAS can affect cholesterol levels, thyroid hormone levels, neurobehavioral test results in children, and a wide range of other health effects. We're also studying the results from our participants specifically here in Hyannis and looking at how information about their water consumption patterns can still tell us something about their current blood levels. And so as these data analyses, are completed and published, we'll be happy to come back and give future updates. So with that, I will hand the microphone back.
Thank you very much, Laurel. Much appreciated. So we're going to hold questions for the individual speakers till the end, but I do hope that you can all stay for that, and I appreciate your patience on that. Our next speakers are from Barnstable County. Paul Rizzula, again, the county asset manager, is going to start us off, I believe, and John Paquin from GZA Geoenvironmental, the project manager or coordinator, will follow up. Over to you.
So good evening. I'm Paul Rizzala. I'm the asset manager for Barnstable County, and I'm joined here with our consultant, GZA, John Paquin and David Leone. We're going to be talking about the former municipal fire training site. So a quick history about the site. In 1959 to 83, it was owned and operated by the Hyannis Fire Department, where in 1987, 1984, it was taken over operation by the county. Throughout its history, it was made available to all 15 towns on Cape Cod, some private entities and towns off of Cape Cod, and it served as a central hub for fire training operations, which was critical. You're a new firefighter, looking to get some experience, so they provided training at that site, valuable training, but it came at an expense where they used AFFF, aqueous film forming foams from 1959 to 2009, which inevitably contained PFAS. One thing to note, as far as our records go, the county essentially coordinated use with the individual fire departments, so therefore we have no records on the actual volume of PFAS used at the site. So once it was determined that PFAS foam was a hazard, we ceased operation in entirety in 2019. A quick detail about the site. So Barnstable County owns the property highlighted in green. That's where the fire training academy was. And it's smack in the middle of two water supplies. To the right, in the blue circles, is the Hyannis water supply wells, and to the left, in the purple, are Barnstable Fire District wells. So as far as a quick history, as far as managing the site, a hot spot where the a concentration of PFAS was found was removed. It was 200 tons was excavated and disposed of off-site. The site was capped. So it was essentially paved over to prevent rainwater intrusion from interacting with the dry soils, pulling PFAS further into the aquifer. There is a groundwater pump and treat system currently active at the site, and the groundwater pump and treat system is indicated by the two red circles. Those are groundwater extraction wells, where it's actually recovering groundwater, piping it to the yellow square where PFAS is being removed, and then the clean water is being pumped back into the ground. Right now, currently, we have plans for a permeable reactive barrier, which GZA will talk about in a little more detail. It's essentially drilling holes along the proximity of the eastern portion of the site and injecting carbon, where the carbon will act as a filter in place to remove PFAS. And that carbon is very similar to what's being used at the Hyannis water supply or all water supplies. It's a activated carbon. So as far as where we currently are right now, we're cleaning up the site based on the Massachusetts contingency plan. The phase 1 initial site investigation is complete. We're currently in the phase 2 comprehensive site investigation, where we're determining the extent and nature of our plume, which we've collected a massive amount of data there in coordination with the town, Tom Cambereri, others that have been involved with the site historically. And we're here with GZA now to go over the details as far as what we're doing now. So I'll hand it over to John Paquin of GZA.
Thank you. So can you hear me? So as Paul mentioned, we were retained in May of last year, and it's been a busy year since we were retained, and it's been an exciting year. We've been very happy and feel privileged to be selected by the county to help them work through this situation. So I told Jim that we would walk through what we've been doing for the last year to give you an idea of what, the progress we've made. I won't go into too much detail on this because we've already presented a lot of detail in past meetings, and I recognize some familiar faces here. And we have another public meeting coming up at the end of July, which will present a lot of the newer data there. So this is an update, and we look forward to seeing you in July. At that meeting, we'll be remote as well. So what have we been doing since May? Well, the first thing we did is we recognized that this was a complicated site involving a number of different potential sources, as Jim mentioned, and involved a lot of people that were interested. So we brought together a group of interested parties. We've been working closely with them, including people from the community, Jim, Brian from representing the airport, now Laurel. We were all working much closely now, and there's communications that go back and forth. The idea is to have everyone working collaboratively to solve a common problem, and that problem is, where does the stuff come from? Where is it going to go? And what do we do to mitigate that? and reduce risk to the public and the environment. Fortunately, as Dan pointed out, right now there's really no risk to the public because they're treating all the water that's being consumed. So you folks have very good quality water right now. So we have time to investigate this and do it right. So the next thing we did was looked at what do we have to work with. So we have a lot of monitoring wells that have been installed over there over the last 10, 20 years. Tom knows them well. He probably drilled 90% of them. And so we started developing an inventory of those wells so we know what to work with, so we don't have to repeat and replicate stuff. We'll use the data we have to save money and be efficient. So we have a very detailed monitoring network, monitoring well inventory, I should say, of our network. We tested them. We did a site-wide test of all those wells to see what we have for contaminant concentrations right now. And we also did a resurvey of all those wells because they've been put in over so many years. We didn't have a good elevation survey, and elevation data is absolutely critical for us because groundwater, like all water, flows downhill. So we need to know what the elevations of the wells are so we can assess which wells are uphill and which ones are downhill and know where the groundwater is going. I hope that that makes sense. We then took that data and looked at the contaminant distribution, plotted it up, mapped it. You've all seen this during our past presentations, the public information presentations we've had. We'll show it again later on in this presentation. We looked at the geological conditions and compiled everything and put together one conceptual site model for the site, including the direction of groundwater flow, which is absolutely critical here if we want to know where it's going. We instrumented our ponds out there. There are lots of water bodies, and those water bodies are in direct contact with groundwater, so we need to know how they're in contact and understand that a little bit better. So we have small diameter instruments in those ponds right now, which give us valuable information in terms of elevations as well as water quality. We then compiled all the data for the fire training facility, the airport, the wastewater treatment plant, into one common database. And that's big because we had so many years of data out there, all scattered into different reports in different locations. And it was important for us to understand what we had to work with again and get it all in one spot. So that was a big undertaking, but it was well worth it because now we have everything in one place and we can plot trends and analyze the data much, much better. We developed a numerical groundwater flow model. That's an ongoing thing. We have a base model that we developed using the U.S. Geological Survey's Cape Cod-wide model. And so we took that and we updated it with the existing local geological conditions and hydrogeological conditions for the site. And then we expanded it, not just to our site, but also for the region, to include, we recognize, as Jim mentioned earlier, this is a big site, involves a lot of people, so we expanded it to include the fire training facility, the airport, the wastewater treatment plant, the Mill Creek area. So all that is now in the model. And we did that with under the review of the U.S. Geological Survey, since we took their model, and they've been very valuable in providing us with inputs as we update and improve their model. We are ongoing. One of the ongoing tasks is what we'll call a forensic analysis of the data. What we're trying to do is try to identify if we have individual fingerprints for different sources of the PFAS based on the individual constituents that have been detected, and look at that backwards in time and think about what might be coming in the future. That's been a challenge, to be honest with you, because so much of the activities at this site involve similar chemicals, that have been used over different sources, different times. And the other challenge, as Paul mentioned, is that no one was keeping inventory of this. So we don't even know exactly what people use and when and where. So it's been quite an effort to try to sort through that, but that's ongoing. And we'll talk about that a little bit more in July when we have a little bit more data that's been analyzed and ready to be released then. But that's a big part of our effort right now. Recently, we installed 16 additional multi-level monitoring wells. So those were wells that are installed with different depths, multi-level wells, from shallow wells to deep wells, installed in areas where we felt we had data gaps. And we didn't understand the distribution of contaminants so well. So we worked with the county, got those wells installed, developed very detailed geologic profiles so we understand what's going on under the ground out there, and then brought all that data back into our groundwater flow model. So we're always updating that model and using the model as a test. Do we understand what's going on here? Does it all fit? We also did a very similar thing with the available data for shallow soil quality. We identified some areas where there were data gaps. So we went out and collected additional shallow soil data, and that's going to be used to assess, impacts, potential impacts to wildlife and natural, fauna and bugs and invertebrates and things like that live out there. So we want to look at that. Going on, what have we been continuing? What have we done since May? We recognize, and we'll talk about this a little bit later on, but we recognize that under the sand, this is Cape Cod, there's a lot of sand on the Cape. There is in this area of the Cape, there is an underlying clay layer, and understanding the depth of that clay layer and its topography, its shape, and whether or not the clay layer is continuous or not was very important to us. We wanted to know if there are holes in that clay layer. And we didn't have any deep data on that. So we had some drilling data, which suggested there was some topography. But what we wanted to do is look at that efficiently. So we retained a very well-regarded geophysical contractor to go out there. And they did a bunch of geophysical surveys using 3 different methods. One was low-frequency ground-penetrating radar, which was able to see geological conditions in excess of 80 feet down, which is very good. And then they compared that to data from a seismic reflection survey, setting off seismic charges or impacts, and then measuring the sound waves coming back. And that data compares. And then the last thing they did is something called electrical resistivity, which is passing electrical currents through the subsurface. And the idea is if you do multiple methods, and those methods all compare well and point it in the same direction, so to speak, that tells you that the data that you're seeing is probably pretty good. So that data came back well, and what it told us is that the clay layer is continuous. We don't have any gaps in it, and it allowed us to map the clay layer such that we now have an understanding of the geological profile along the site boundary, and that's going to come up when we talk about the PRB that someone mentioned earlier. So the other task that the county asked us to do is take over monitoring and somewhat management of the ongoing pump and treat system out there. So we've been doing that and recommending to the county ways to improve that and make monitoring and maintenance more efficient. So that's also ongoing. We decided early on that rather than expanding the groundwater pump and treat system that had been expanded or installed out there, we thought, that's very expensive and it involves pumping a lot of water. You have to treat a lot of water, and then you have to discharge back into the subsurface. Very, very labor intensive, very costly, and not necessarily very efficient because of the volumes we're talking about. So we felt that a more efficient way of dealing with this would be to install this PRB, or permeable reactive barrier, in the ground. And when I say install it, what I'm really meaning is to take a small diameter drill rig and push a small diameter probe to depth, which in this case would be to the top of that clay layer that I spoke of, because that clay layer is going to function as a lower confining layer to prevent contaminants to move through it, because the clay is so much less permeable than the sands above. So what we did is just to see if that would work, and what we're injecting, by the way, is something called colloidal activated carbon. And what that is simply activated carbon, like Hans uses at his facility, but it's been ground down or milled down to a very, very fine dust. It's actually 20 microns, so it's really, really fine stuff. And what they do then is mix it into a slurry with water. And then, so they drive those probes to depth, and then they pump that slurry through those probes. These are small probes, like 1 inch diameter. And then they pump that through those probes, and then they pull back the probes as they go, so they're injecting this colloidal activated carbon in liquid form from the top of the clay all the way to the top of the water table. And then they move that along, they move the rig along and ultimately install a wall, or if you think of it as a rough wall, along your targeted area. And that carbon then stays in the ground, and it works much like Hans sees at his treatment facility. It's the PFAS constituents sorbed to that carbon, and now they're bound up in the soils, and they don't migrate further down gradient. So the idea here is, as Paul mentioned, they already capped the site, which prevents surface water precipitation from infiltrating into the ground and maybe mobilizing contaminants that are in the shallow soils. And so that takes care of things in the vertical direction. But this PRB should help to take care of containing the contaminants in the horizontal direction. So we put that in along the site boundary, the down gradient boundary. We limit the amount of water that's coming in from the top, and then we limit the contaminants from migrating much further beyond that PRB, permeable reactor barrier. Then the contaminants are restricted to the site in large part. So that's the idea, is that if we can keep it restricted to the site, then they're not hurting anyone. They're staying right in place, and concentrations down gradient of that, hydraulically down gradient of that, should diminish because we've cut off the source of the contaminants. And if those concentrations diminish, then Hans finds himself using less carbon at the treatment, at the wellhead treatment, and risks go down. So that's all a good thing. Okay, less carbon, less treatment costs. So we did a pilot test for that last year, and the pilot test studies are very positive right now. The results are very positive. It showed that we could inject it, and the initial testing results are excellent. We have non-detect concentrations of the regulated PFAS 6 compounds that we're targeting here. And so we went from having higher concentrations. We actually did the pilot test downgrading to that hot spot area that Paul spoke of, where the concentrations were the highest. And we put in the pilot test section, injected it, and downgrading to that in a series of wells that we installed. Concentrations now are non-detectable. So that's a very positive thing. And with those results, we feel comfortable recommending to the county that we take it from the pilot test to a full-scale installation or injection. And we want to do that sooner than later to prevent further migration of the PFAS constituents towards the Mary Dunn wells. So pilot test is technically ongoing because we want to get at least a year's worth, but we feel comfortable enough to say, let's start injecting for the full scale. This is going to work, okay? So we worked with the county to put together a competitive bid package, sent that out to 3 major firms doing this kind of work, and they all bid on the project, and we selected one firm based on cost and qualifications, but they ended up being the low bid. That firm has been selected. They are under contract to the county, and their costs are being funded by a federal grant right now. So that's all great stuff. So the plan right now, and I'll talk about this, I'm getting a little bit ahead of myself, but the plan right now is to start injecting that carbon as part of the full scale next month in mid-July. So this is moving along very quickly. When Paul brought us on board, he told us he wanted to move this project along quickly, and I think we're doing that. So to support that, we recently installed 27 new, what we're calling performance verification wells. And these are wells that are installed along the alignment of the proposed PRB. And they're installed so we get background data before we inject the carbon, and then we'll have the ability to monitor water quality upgrading to the PRB as well as downgrading to the PRB as time goes by, and verify that the PRB is working, and assess if we have breakthrough or not in the carbon. So those are all installed. So this I'm going to switch to this pointer right now. Oh yeah, please do. Thank you. Yeah, so this figure shows the alignment of the PRB as of right now, and it goes along the hydraulically down gradient side of the site. So groundwater is flowing from the west to the east. So this is catching it as it's leaving the site and treating it there, and we'll monitor it along the property line as well. Okay, we did encounter, there are some wetland areas on the south side and the north side, so right in that area. We're encroaching on the 100-foot buffer zone in that area. So we went in front of the Conservation Commission, explained what we were doing. They fully agreed with us and approved our actions and so our proposal. So that's resolved as well. I really did get ahead of myself with my babbling, but I hope you don't mind. So we injected the colloidal activated carbon to the top of that clay layer, as I said. We talked about PFAS sorbed to soil. This little graphic is kind of nice in that it kind of conceptualizes what we're talking about. So concentrations on the left side of the drawing are where the concentrations are higher. If the groundwater flows through this barrier, it's really not that clean because this barrier, the carbon spreads out when it goes in on the ground, when it's injected. So it's an area. Think of it as an area, a carbon area or a zone, and that carbon zone, works to absorb the PFAS constituents to the carbon and fix it in place. And then on the right side of it, we have concentrations that are much lower. And in our case, for the pilot test, they're non-detectable. Okay. So here's another graphic of the PRB location and the geological conditions associated with that. This is a geological cross-section, and think of it as a cut, a vertical cut through the soils along that eastern property line from A to A prime there. So now we've tilted the drawing so the north is to the left here. And I just want to show you that, you can see here the silt layer at the bottom, or silt and clay layer at the bottom, which is much lower in permeability. I know it probably doesn't mean a whole lot to you, but permeabilities of the sands are on the order of 365 feet per day. That's the measurement we use. In the silt and clays, they're on the order of less than 1, okay? So much, much, much lower. So that effectively functions as a low flow or impermeable boundary because water wants to take the path of least resistance. It's not going to go through the clay when it can go through the sand, okay? This also shows the contaminant concentration. So those blue lines there are lines of equal concentration. And that area where Dave is pointing is our hotspot area, right in that area. That little area is our highest concentration. So that's down gradient or hydraulically down gradient of our hotspot. So that's exactly where our pilot test went. The pilot test went in right at the corner there between, right there. That's where we put in the pilot test, okay? So here's a little background. Once I got through what we've been doing, I wanted to share with you what we've learned. So what we've learned up to this point is, this is a plan showing groundwater elevations, and from that we can assess or infer groundwater flow direction. So these lines are lines of equal groundwater elevation, and as I said earlier, groundwater flows from high elevation to low elevation. So what we're seeing is a consistent gradient from the west to the east to the southeast. Very consistent with what we'd expect, consistent with what Tom has been measuring for the last 15, 20 years out there. So it all holds together well. What we also see is that there are some concentrations on the upgradient side of, I went too fast, and we'll get to this, but in that area there that are actually upgradient of the fire training facility, and we'll talk about that as well. But I wanted to just put it in your mind that those are upgradient areas there. Okay, so this is a map that shows a graphical depiction of the extent of contaminants in the shallow groundwater back in June when we did our first site-wide comprehensive site groundwater monitoring round. And what it shows is that the pond is impacted, Flint Rock Pond is impacted, and we have a plume migrating from the site, migrating down to the southeast towards Mary Dunn Pond and towards the Mary Dunn Wells. And then if we look at it, and we also see there's some question marks to the south there. And those were areas where we had questions about the extent of that, so we identified those as data gaps. So those were areas that we targeted with those new wells that I told you that we installed. So this is another figure that I like in that it shows the concentrations in the deep groundwater, but it also shows where the site and the deep groundwater plume fits in relation to all the neighboring things that are going on around that site. So it shows, you can see the site again, if you can just, there it is right there. And we have our plume of PFAS constituents migrating, again, similar to the shallow, to the southeast. But we also see concentrations in the Barnstable Fire District wells that are up gradient of us. And the only way that gets there, unless we defy basic hydrogeological principles, is that if it comes from someplace up gradient of us, because it doesn't flow uphill. So that's an area that, it looks like maybe there's something coming in from an offsite source in that area. We're still evaluating the data, but that's what our thoughts are right now. With the plume migrating towards the Mary Dunn Wells, and it's heading right for the airport plume. So they are starting to commingle in that area. So one of our challenges now, as we look at the data with more detail, is to figure out how are they commingling, if they are. Brian will talk about that as well, and make some conclusions on that to the extent we can. You can also see where the wastewater treatment plant is there to the southwest. And we're trying to assess, is that an issue as well? Is that part of this story or not? So I have to say, we're so excited and happy that all players are working so well together. And the town and Dan has been great in giving us access to the wells at the wastewater treatment plant, so we don't have to drill anymore. We're using their wells. We're sharing data, sharing instruments. Same thing with the airport. And so all that is coming together nicely. If we share all that data, we can all interpret it. And the data is the data. It all tells the same story, hopefully. Okay? So that's a nice drawing there to show the area-wide issue. So that's what I have in terms of where we are at. Actually, what happened to my next step slide? Okay, I had a slide in there that disappeared. Jim. So there was a slide in there that said, what are we doing moving forward? And it said exactly what I said earlier. It says we're putting in a PRB in July. It said that we continue to analyze data. We're still doing the model, updating the model. And our work with the model, again, is very cooperative, working with USGS, also working with Tom's group, who's did his own model, and we're comparing notes because, the data's the data again. And we're working with Laurel's group there the same way. So all that's coming together. And lastly, the thing I wanted to share with you, as I mentioned earlier, is that we have a public meeting coming up on July 29th. And that'll be a remote meeting, so you can log in from home. And we'll be sharing some recent data for samples that we collected in May. And we just don't have them analyzed yet. We just got them from the lab, and we're still analyzing them and analyzing the data. So we don't have that available to share with you tonight, but we should have that available to share with you in July. So we hope that you all log in for our meeting in July. Okay. Is that helpful?
Thank you. Appreciate your input. It's very, very useful to see exactly what's happening at this point at the county facility. There's a lot to go there, I think. Our next speaker is Brian Massa from HRP Associates. He's going to be talking about the airport site. So bear with us. There's one more to go, and then we'll be moving towards our conclusions.
Hey, everybody. Brian Massa, licensed site professional, principal with HRP Associates. I'm also the airport's LSP of record. I appreciate the opportunity to give you guys an update on the work that we've done. I'm going to focus a lot of my talk on the recent work that we just did in Yarmouth, because I know that's something that a lot of the folks are interested in. We've also been, working a lot with GZA and other folks in a collaborative effort, so it's been really exciting. So for today's discussion, I'm going to give you kind of a general PFAS investigation timeline, a little background on the airport's work, the recent stuff that we've done in Yarmouth, nature and extent of what we know for the airport's impacts, some discussion on the results of our CAP monitoring. The airport capped both of its PFAS sources in 2020, so we've been monitoring them for the last 5 years. Also talk about conclusions, kind of where we are now, and then what our next steps are. So the airport began its investigation in 2016 at the request of Mass DEP. Between 2016 and 2025, we've collected over 135 soil samples for PFAS analysis, 285 groundwater samples, 12 fire truck spray samples, and then 9 surface water samples. Surface water samples were collected from Uppergate Pond, Lewis Pond, Mill Pond, Hawes Run, probably pronouncing that wrong, so I apologize, Town Brook, Mill Pond Marsh, all for PFAS analysis as well. So right here is kind of an overview of our sampling locations. I'll do some pointing here and hopefully kind of walk you through what this is. So all of the red dots that you see up here, these are all monitoring well locations that the airport has used to delineate the nature and extent of its plume. And like what John was saying earlier, is there's a lot of PFAS sources out here, and we've been relying a lot on environmental forensics to figure out airport-related sources versus non-airport related sources, just so we can kind of figure out what's going on. So over the course of the last 8 years or so, the airport's collected a significant amount of groundwater samples and installed monitoring wells and clusters. So last month, in coordination with GZA, we tried to collect a large data snapshot in time. So to collect on the airport, off the airport, down at the Mar Wells in Yarmouth, as well as at the Fire Training Academy, to really collect a good snapshot of what's going on so that we can kind of review that as a group to help answer some questions. So all of the yellow circles that you see in here are locations that the airport just recently sampled last month. So that data has been coming in. The outline that you see here is the airport's plume over here and over here, and that was based on modeling. We also used the ModFlow model a couple years back, and we predicted what the airport's plume would do. One of the things that's difficult is that there is so much PFAS in this area that we looked at, if the airport was the only source, what would its plume do? And this was based on modeling and then confirmed by analytical data. So our model had indicated that the plume stopped here, and there's been a question of if our plume continued and went into Yarmouth. So back in April, we installed 2 monitoring well couplets down here and then down here that it would be downgrading of our plume area. And the couplets have a shallow monitoring well, an intermediate well, and a deep well, so we can screen those different zones to see, because PFAS can act like a DNAPL and can sink. So we really wanted to make sure, what was going on there. We also collected surface water samples. We collected surface water samples that are up gradient of the Mill Pond area over here and over here. Also collected them next to our monitoring well location over here. We collected down in the marsh area. This particular location was very difficult to do, and we appreciate access from Hans and some hiking that had to happen to get that in. We also collected surface water sample down there. All of those samples were collected recently. Again, kind of gives us a snapshot of what's going on. So here's the results of the Yarmouth work. So the 2 monitoring well clusters here were non-detect for 6,2 fluoropolymer. So the airport has purchase records for the last 20 years indicating that they used a fluoropolymer-based foam. And part of our forensics looks at what analyte is associated with a fluoropolymer-based foam. It's regulated and unregulated analytes. PFAS 6 is in there, but it also contains 6,2 fluoropolymer at higher concentrations, which allows us to look at data quickly to say, well, 6,2 fluoropolymer is in here. It's likely associated with the airport. 6,2 fluoropolymer is not in here. It's probably not associated with the airport and others. So it was a forensic tool that we used as a screening. So our model had indicated that our airport's PFAS plume would come into the Mill Creek wetland area and would be discharging into that wetland area, and that the impacts would stop there in groundwater and it would become a surface water discharge. We also monitored that by the time the airport's plume, again, only the airport's plume, had migrated down to this area, that the regulated analytes by themselves would be less than the GW1 standard. However, 6,2 fluoropolymer and other analytes are in there that there aren't any regulatory standards for. When we collected our surface water samples, PFAS 6,2 fluoropolymer was detected in 2 of the surface water samples, which is what we had expected, down gradient of the Mar wells, this one right here and this one right here. This one, analytical data is still pending, but we expect that we will also see it there. 6,2 fluoropolymer was not detected at this location or this location, which we also didn't expect to see it there because it's up gradient of the airport. But what we did document is that there is PFAS entering the system up here and up here. Sources of that, not really known. There's residential areas up here. There's also a fire response area up here for the town of Yarmouth. And then there's roadway runoff that's entering in this area too. So other sources that are also contributing to the impacts down in this area. 6,2 fluoropolymer was also not detected here, which again is consistent with our model, and not detected in groundwater. So another thing that I want to talk about is the 2 airport caps. So this is a concentration trend line that kind of shows what the concentrations were in the deployment area, which is the airport's significant source. That's the much bigger PFAS plume that you see. And what it shows is concentrations. This is total PFAS. So total PFAS would be the sum of all 1633. There's about 40 analytes that are reported in the method, just all summed up. That includes regulated and unregulated analytes. Sum of 6 is the concentration down here. Those are the 6 analytes that are regulated by Mass DEP. And then this green one right here is that 6,2 fluoropolymer analyte. So what you see right here is when we started, before we put in the cap, the concentrations of PFAS were going up. We were about 16 parts per billion total PFAS. About 12 of those were related specifically to 6,2 fluoropolymer, and the other 2 were related to unregulated analytes. When we installed the cap right here, you see that there's a drastic drop in concentration, and then you see kind of these fluctuations. I've circled them in purple where it goes up, and then it drops back down, and goes up a little, drops down, goes up, drops down. That's expected when you install a soil cap. So what happens is in this area, there's still impacts that are in soil in the capillary fringe zone, which is the area, a couple feet above groundwater. And as groundwater goes up and down, it's picking up those contaminants and flushing them out. So these peaks that you see correlate with rises and fall in the groundwater. Now, the thing that's very interesting, and it's one of the things that we're looking into, is we installed a new monitoring well that's hydraulically upgrading of the cap area. The data for that hasn't come in, it's pending. But what we see is the cap had a drastic effect on total PFAS and 6,2 fluoropolymer, but no effect on the regulated analytes, which is very, very strange. To see swings like this with almost no change is indicating that there may be a background concentration, because the cap will only treat a source. If there's other PFAS that's migrating into the area, it'll have no effect on that. So one of the things that we did is we installed, let me go back to this figure right here. We installed a monitoring well recently right up there, which is hydraulically up gradient, because we want to find out, is the cap actually working? The analytical data suggests that it is, but we want some more data points to prove that. So this is, a summary of what we found in the recent work, and then I'll get to some next steps that we're looking to do. So the analytical data collected down gradient of the cap. Analytical data collected down gradient of the deployment area cap suggested it's functioning as designed. The data that we're getting now is consistent. It's showing the up and down trends, which we expect it to happen as it flushes itself out over the next several years. All regulated PFAS analytes detected in groundwater are consistently less than the GW3 standard. So the GW3 standard is protective of surface water. Currently, there are no surface water standards. The groundwater and surface water data collected in groundwater is consistent with our model. So our model did depict that the airport's plume would discharge into the marsh, that it would go into that area. Concentrations for regulated analytes were expected to be at the GW1 standard by the time it got to Mar Wells, and then would dissipate as it moved into the marsh, and that groundwater outside of the marsh area would not be impacted. And that was confirmed with the new monitoring wells that we installed. The PFAS detected in the Mill Pond area is consistent with the airport, which again is what we had expected. And it also looks like there's other non-airport related PFAS sources in there. So the airport's next steps. They're going to continue with the PFAS groundwater monitoring, surface water monitoring, and provide updates to the Phase 5. We're going to continue to collaborate with Mass DEP, Barnstable County, Town of Yarmouth, and other stakeholders. We're going to work with a risk assessor to develop risk-based groundwater and surface water criteria for unregulated analytes, including 6,2-fluorotelmer and others, just because the data is not there. There's no regulatory standard to compare it to. We're also going to evaluate a new PRB technology. So John talked a lot about PRBs and kind of what their effectiveness is. And the airport also evaluated PRB several years ago, but for various reasons at that particular time, it didn't make sense for the airport to install a PRB. Now there's new technology in place, and it may make sense for the airport to install that. So that's something that we're also going to evaluate over the next year or so. That's it.
Thank you, Brian. Before we get back to Dan Santos and closure of the meeting and going to questions, I wanted to just take a couple of minutes to talk about the bigger picture here. So I've been looking at the investigation reports, going to these meetings, collecting information, reviewing historical information for close to a year now. And I think a picture is really developed here that helps us all understand what's happening with PFAS in the groundwater in the area of Hyannis. So I want to just kind of go over that. And this is based on work that's done by the county. It's work by the airport. It's work by Tom Cambreri and Sole Source Consulting, and including a study he did for the DPW a few years ago, looking at PFAS in groundwater and ponds as part of an assessment of potential new water source areas in town. So we have, as I mentioned before, the clusters of water supply areas, the Mary Dunn wells, the Mar wells, and the Straightway wells, all bunched together, Simmons Pond and Hyannisport with Straightway. We have the sources, the Barnstable County's facility, fire training facility here. We have the airport here, and particularly in this vicinity to the southeast of the airport, where Brian's work has identified the sources of contamination, and he's gone from there with the assessment of the extent. Historically, these releases of PFAS started a long time ago, decades ago. And groundwater moves through this system pretty fast. Foot per day, faster in some places, a little bit slower in other places. Foot per day is quite fast for groundwater, but it's had time to migrate long distances. PFAS moves with the groundwater flow Certain PFAS compounds may move a little bit faster than others. It's a complicated system. But what we see that's happened is migration from the sources to the well fields has resulted in water taken up by the well fields and redistributed across town. Because these compounds don't break down over time to any great extent, the water that's taken in for household use and goes out to the wastewater treatment plant holds the PFAS that was coming from those source areas getting into the water supply. So as a result of that, the Barnstable Water Treatment Facility is what's called a secondary source. It's redistributed PFAS that was extracted from the groundwater in other places. That's resulted in a spread of the PFAS contamination over a far greater area than might have been the case if it was just a plume migrating from a particular source. And because of the nature of the discharge at the wastewater treatment plant, you get flow in more than one direction moving away from the plant. So the airport saw a secondary plume that was moving across the facility towards the Mar wells. Likely that is associated with the wastewater treatment plant. There are no doubt other sources of PFAS in the town as well, that where there have been release sites that we don't necessarily know about yet. There's also a number of sources of PFAS that add to it. There's atmospheric deposition of PFAS in Massachusetts. There's been studies that have shown that. But we can't achieve the high concentrations that we're seeing in wells like the Straightway wells without a source that is a significant source affecting it. And likely flow to the south from the Barnstable Water Pollution Control Facility has impacted the Straightway wells, Simmons Pond and Hyannis Port as well. So it's become a very complicated situation and a widespread problem, which really necessitates a focus in the end on treatment of the water supply, because it'd be very difficult to address all the sources to the extent they would need to be addressed to prevent contamination getting to the water supply, at least in the near term, and near term could be, in the form of decades. So it's key that the water treatment continue, and at the same time, these sources of PFAS, the concentrated sources, be addressed. There are question marks on the figures that have been shown about the extent of contamination from the county's facility. But given the time frame and the concentrations of PFAS, we expect that in the end, when they collect all their data, you'll see that it's migrated pretty long distances. It's going to be a complicated process to tease that out, and GZA is doing a great job with that, and the airport and Brian has done a good job with that as well. But it's key that we keep Hans on board, treat the water as an essential activity. So Dan, I'll turn it over to you at this point. If you.
To your comments and questions and concerns.
Okay, all right. So we will move on to questions and discussion. We have microphones. I'm going to get the cards that people filled out. So we invite questions to the presenters, as well as if you want to make a brief statement, please feel free to do so. And Kelly can bring a microphone, or you can come up to the front if you would like. So we encourage your questions. Okay.
Hi, my name is Betty Ledke. I'm a resident of Hyannis. I participated in the Silent Spring test. I and my children were all impacted by that. I find this refreshing and disturbing. Refreshing that we're finally getting, I think, some answers, some discussion, some commentary that is based in the truth. And I think we're finally getting some movement on this. What I find disturbing is that we're still saying, and I've said this many times before, you know, thank God for the Mahar wells because they solve all evils. Because that's, you know, and you just said it there, you summed it up. We've got to keep relying on treatment. Well, gosh darn it, why don't we clean it up? And that's what I'm finally hearing from the county. But you guys have been a little slow in the game, but now you're doing a good job. But I do find it disturbing that, you know, finally I like the talk from the treatment plant about the secondary source. You said, and we're not getting the levels we had without sources. And I would like to see some comparative data. You put up the level of contamination in our wells. How does that compare to other municipalities across the United States? How does it compare to other municipalities on Cape Cod? I mean, we just keep letting this PFAS flow, and it's going beyond the Mahar wells. They're not solving all evils. And we say that there are no regulatory standards, correct? But yet we're eating the seafood that is coming from all the PFAS water. So, I mean, this is such a conundrum, and I'm glad the permeable barrier, airport, thank you. You said you're thinking about that now. I know at the last meeting in October you said, no, we're not going to do that because you said you'd get overloaded by unknown PFAS, but maybe there's more knowns now. So good on the airport for doing that, because the airport has been one of the ones that, again, the Mahar wells solve everything. Well, they don't. I don't like that, because we wouldn't have had this secondary source at the sewage if we'd been more proactive in cleaning these up and not just letting the Mahar wells do everything. I'm also a ratepayer from Hyannis, and as you said, it's very expensive. You said we could have maybe less expense. So I could go on, but so again, thank you. I think we're finally getting some honest commentary here. It's troubling. I'd like to see more effort on cleanup. We really should be doing cleanup. We can't just keep relying on these wells. Yes, we've solved that. I'm drinking clean water, but it's just not right. Sorry.
Thank you. And I certainly didn't mean to imply that further cleanup shouldn't be taking place. The Mahar wells are protecting the public health now, but as you say, the full extent has not been defined, and there may be other impacts that need to be assessed. So this work is necessary, the assessment work, and it's ongoing. I see that there are a lot of questions here about the cost of treatment that the town is and ratepayers are funding. And I don't have specific answers to that, but I think that there are several questions here that relate to the treatment system. And what we can do with that is put together some information that can be put up on the DPW's website, so that the public has a source of information on issues of cost of treatment and how efficient it is. And that's another question that we had. I wanted to say that with regard to other towns and on the Cape or other parts of Massachusetts, the concentrations that you have in the groundwater and that are affecting these wells are higher than most places, certainly. I also want to say that the finished water quality that's sent out is better than most places in Massachusetts. There are a lot of towns that are supplying water with higher concentrations to the public. So I want to turn it over to Laurel, if you can address a couple of the questions that came up.
Sure, happy to. I'll read them first. So the first question said, you presented median levels in blood. Can you discuss high levels of exposure detected in Hyannis residents? So there's a couple of ways to answer that. So the more complete presentation that I did last year talked about sort of the full range of levels, not just the median level. So obviously there was, that's the middle level, so there were people who were higher, and certainly some people who were far above the median. I will say that compared to the other sites in the study, our site was higher than some, lower than others. When we reported our results back to study participants, we shared information from the National Academies of Sciences 2022 study panel. This was a panel that was intended to inform clinicians and to improve healthcare for people who'd had elevated exposures. So as part of that National Academies report, they made a strong recommendation that for people who'd potentially had elevated exposures to PFAS, that they be offered PFAS blood testing. And then the members of the panel also put recommendations together with respect to medical screening, with the idea being that for people who'd experienced elevated exposures, that there might be certain types of screenings that might be appropriate. So if we know that PFAS can raise blood pressure, can lead to higher cholesterol, potentially affect thyroid, liver, kidney function. We didn't get into all the types of health effects associated with PFAS. That's something that doctors can be aware of, and there might be some screenings that are appropriate. And so they had a couple of benchmarks in terms of PFAS blood levels and screenings that are appropriate. And so participants in the study received that information. And this kind of ties to the other question that I'll answer and try to address both at the same time. So the other question here is, it's a little bit long. For those of us who participated in the Silent Spring study, I'm concerned that we now have information about PFAS blood levels, but no information about how to mitigate our exposure and improve our health outcomes. Do you agree that the town of Barnstable should take a leadership role along with Cape Cod Healthcare to inform the public about their possible exposure and undertake an effort to deliver to the public timely information and therapies to remove PFAS from our bodies, and get in front of testing, expose residents for possible health problems known to be caused by PFAS. Additionally, the town can take a leadership role to stop PFAS from continuing to make its way across Cape Cod. So to kind of put those pieces together, I do think clinician engagement is an important piece of this. Silent Spring Institute has created a continuing medical education course, and we're always open to talk to clinicians. We've done some presentations to Cape Cod healthcare pediatricians, and we'd be open to expanding that work because I think informing clinicians is a part of that equation, so that doctors can know maybe what to look for to provide some extra screenings for people who've been exposed. There are a couple of studies that are out there. I know for people who've been exposed and have high levels in their blood, they might want to know whether there's anything to do to more quickly lower their levels. Certainly putting in place the water treatment is the important first step, and we know over time the levels will go down. There are studies out there. So one study of Australian firefighters that looked at blood donation or plasma donation as a way to reduce PFAS levels in the body. We know PFAS bind to proteins in the blood, and so that is a way to lower levels. And then a second study looked at a medication called cholestyramine. It's an older cholesterol medication. And in the C8 study, anyone who watched Dark Waters, a major health study conducted in West Virginia, among participants in that study, there were a small number of people taking this medication, and it was found that they had low levels of certain PFAS in their blood. I'm not a medical doctor, and it's not something that's sort of standard medical care to recommend those types of steps to reduce exposure. I know people have expressed interest in that, and some have tried that. And so I'm not in a position to say whether or not that is a good way to go, but I know people read papers about those, and that's something people have questions about. But certainly medical screenings to track PFAS or track health effects that might be linked to PFAS exposure. And I just think for clinicians to be aware that this is part of people's past medical history and to think about that for protecting future health care. So I hope that answers the questions.
Thank you, Laurel. I've got a card here that has a related question. I'll read this one off. When will the town of Barnstable send out a notification to all residents advising them of the significant PFAS contamination in their water? Notification should advise residents of risks and advise them how to go about getting more information. And this is a very important aspect of this. There's a lot of sources of information, but they're hard to find sometimes for people. So DPW has a website dedicated to PFAS, and I know there's information there. I think we can focus in on that and look at exactly how well it's linked. Okay.
Yeah, so I'm happy to respond. Kelly Colby, Communications Manager for the Department of Public Works. So as Jim noted, there is the Town of Barnstable website, and on that website, all of our various town departments are listed, including the Department of Public Works. On that Department of Public Works webpage, there is a page dedicated to the Hyannis water system, which Hans has provided a bunch of information, including resources regarding PFAS exposure and a variety of other resources in just related to the Hyannis water system. With that said, the town of Barnstable's DPW also manages our own Barnstable Water Resources website. That website was primarily dedicated to the comprehensive wastewater management plan, but we've since expanded and continue to expand the content on that site, more recently to include PFAS resources and education, and then some of our future Hyannis water system projects. So you can certainly check out both the town website and the Barnstable Water Resources website. And then we did pass around the sign-in forms. We have a dedicated newsletter associated to the Barnstable Water Resources website, in which we will provide additional information, the recording for this meeting, any questions or responses that we need to share in addition to the meeting recording, a summary of the meeting, and then we can also share the links to those PFAS resources as well. So we're really making a concentrated effort to bring all of our water quality and water resource information under the Barnstable Water Resources website to make it much more easy for our community to find.
Thank you. I've got another question here that is, while groundwater PFAS levels are not regulated, and I assume this refers to some of the compounds that Brian was talking about in particular, do we know what the impacts are on human activities in our coastal embayments? Lewis Bay, is it impacted by the PFAS plume? So I'll turn to Brian to address that to a certain extent, because I know one of the things that he mentioned is doing some work looking at sort of the ecological risk.
So one of the things that's difficult is there's not that much information on the effects of these unregulated analytes. Everyone pays a lot of attention to the 6 regulated analytes, the PFAS 6, analytes regulated by EPA, but there are all of these other analytes that are detected that we have no regulatory standards for. The thought is that those are less toxic analytes, which is why they're not being focused on. They focused on the ones that they feel to be most toxic. But that data isn't really out there. But what has happened is over the last couple years, additional information has become available to do risk assessment work. So one of the steps that the airport is going to be doing is to work with a risk assessor to look at what the risks are associated with these unregulated analytes that we have, that there are no regulatory standards. So we're hoping that we can develop groundwater-based standards and surface water-based standards that are protective in working with a risk assessor. So that's one of the things that will be happening in the near future.
Thanks, Brian. I have several cards here that ask questions about testing of water at households and of whether or not people should be putting in filtration systems at their house. What I can tell you is that the water quality that you're receiving now is the highest possible water quality, with regard to PFAS. Adding a filtration system at your house is not going to help. I personally have a filtration system at my house because my town hasn't put filtration on the water yet. And it's going to take many years to get in place, which is not great. So One, I don't think testing is necessary at your home if you're on the municipal system. If you're on private water, that's another matter. And filtration won't do anything but spend your money because this water is very well filtered. Okay. There was a question that I passed down to GZA, and I'll turn it over to you folks to take a look at that.
So I'll read the question. The question says, GZA says no risk to the public. Please clarify. And then there's a series of bullets. So bullet number 1 is exposed individuals may face significant health risks for remainder of life. Number 2, private wells. Number 3, consumption of contaminated fish or shellfish. Number 4, ingestion of contaminated surface water in ponds. Number 5, consumption of veggies grown on contaminated soil. 6, ingestion of PFAS from handling contaminated soils and sediments. So when I made the statement that there's no risk to the public, it was absolutely in line with what Jim has mentioned and Dan and the commissioner, what you mentioned, and that is that the town, the Hyannis Water District is currently distributing very good quality water. So that is a key driver of risk, in that the exposure is much higher that way, because we're at home, we're drinking the water, we're at, in our places of business, we're drinking the water. That is a direct consumption, higher level exposure pathway for direct consumption of contaminants. And in this case, when the town and county learned of this, they immediately installed their treatment systems. That cut off a major, major exposure risk. So that's why I made that statement that there's no risk to the public for consumption of the water. And that's the focus of our study, is the groundwater and the risk to the Mary Dunn wells and the like, and the other wells. So going down the list, as far as individuals may face significant health risks for the rest of their life, that's the past exposures and assessments that Laurel is looking at. But fortunately, right now, the chronic ongoing exposure has been mitigated. Number 2, the private wells. When we got involved with the project, the first thing we did was look at what's down gradient to the site, and are there any private wells? Are there any residences? And fortunately, there are none. The land between the fire training facility and the Mary Dunn wells is mostly woodland, undeveloped land. There's some industrial land, but there are no private wells. Everyone's on public water. So once again, they're all drinking good quality water with that meets all the standards. So it's excellent quality water. Number 3, consumption of contaminated fish, shellfish. That is something that, like Brian, we are looking at ecological risks. Although consumption of the fish, it goes beyond ecological risk. It goes back to it's a human health exposure pathway, someone eating the fish and they're exposed that way. And that is something that we have to look at as part of phase 2, is the human health risk. But that can be mitigated through institutional controls that say, don't eat the fish in these ponds because they're impacted, which makes common sense, I think. Same thing with shellfish and the like. And again, I wanted to, this was addressed at GZ. I wanted to stress that's the focus of our study, is the fire training facility and the plume migrating from the fire training facility moving downwards. We also are going to be initiating actually we've already initiated a ecological risk assessment. I didn't mention it during my study, my talk, but we're initiating the data gathering for that ecological risk assessment next week. We're going to be deploying light traps in the ponds and in the wooded areas to collect bugs and assess what kind of PFAS is in the bugs, and then from there we do a food chain analysis. The bugs are consumed by other bigger animals, and so on and so on. So we want to look at that as well, and we will be looking at that as well. So ingestion of surface water in ponds, I hope no one's drinking surface water in those ponds, but that's something that, we'll have to look at, and if there are appropriate institutional controls that say, don't drink the water from these ponds, that's a good thing to do. Consumption of veggies, again, for our site, there's no one growing any veggies, there's no exposure pathway that way. And injection of PFAS from handling contaminated soils and sediments, same thing. We are looking at the entire site, and under the Massachusetts contingency plan, the entire site is where the contaminants have come to be. So we're looking at all of that right now. Is that helpful?
Very helpful, thank you. Speaking for the crowd. Yes, sir.
Perhaps you discussed this. You talked about the Hyannis water supply. Did this include all the other villages as well? Like Centerville, Austerville, Marston's Mills? Or are they separate?
It does not. We're focused tonight on the Hyannis
Just
water
Hyannis,
system.
okay. So any studies on Centerville, Austerville, Marston's Mills, anything planned for that?
I defer to Dan.
I don't know, they're separate
Okay.
municipal entities, so you'd have to speak to them.
I just wonder if you've taken great measures to solve the problem, and just wonder if they're trying to do that as well. I don't know.
They have requirements to sample
Okay.
and analyze, and so I'm sure that they are doing that work in accordance with the requirements of the Department of Environmental Protection.
Okay.
But any details about that, you'd have to.
Okay, because I live in Centerville, so I was curious how that was going.
Sure.
Okay, thank you.
And just to add to that, Massachusetts has had a standard for PFAS 6 since 2020, so all water supplies on the Cape have had to test for and treat for PFAS if they're an issue. I don't know the Comwells offhand. I think they have had some with some PFAS. I don't know if they've had to put in place any treatment. Hans is nodding, so maybe got a thumbs up from Hans. So because Massachusetts has put in place a standard before EPA acted, as a state, we've been better protected from PFAS than some other states. And you should be able to, from the Consumer Confidence Report or by contacting the Water District, find out about PFAS levels, because they are required to test for PFAS and to make that information available.
I just wanted to note that the Water information is on the DPW website. So you can go to the DPW homepage and get to that information looking at the water supply section. Yes, sir.
Thank you. A question for the county, please. The filters at the Mayor Wells are replaced every once in a while. How long will the permeable barrier be effective? Will you just test the water that's down hill from it and then put new barrier in there, or how does that work? Thank you.
The short answer is yes, and you know exactly what we're doing, and you should be working for us. So the short answer is absolutely. We will be testing down gradient, and that allows us to assess if we're consuming carbon and if the carbon has broken through. So carbon works because each granular carbon has a finite number of positions on that carbon granule that contaminants can absorb to. And once it becomes full, it can't absorb anymore. So we monitor water quality to make sure if we have breakthrough. Once it gets full of contaminants, and it can't absorb anymore, we call that breakthrough. So we will be monitoring that. And the solution to that is if you do have breakthrough, then you add more carbon, because you can always inject more. This is not construction of a trench or digging, excavating, or anything like that. That's the nice part about this, is that it is simply driving small diameter probes to depth and injecting a slurry. So it's very quick and relatively easy to do. In terms of the number of years, well, the jury's out on that, to be honest with you. I'm not gonna sugarcoat that. It is a relatively new technology, and it's within the last 10, 15 years. And so when we were looking at this, we spoke with some major vendors, including the vendor we ended up selecting for this site, and they were one of the first to use it under a proprietary name. and their oldest site is a site in Canada, in Ontario. And, so I asked for the data from that site. The site's about 12 years old right now. So every site's different. Every site has different geological conditions, different flow rates, different grain sizes, different contaminant concentrations. So it's hard to say one is directly proportional to the other or directly correlates with the other. But at this point, 3 years ago, 4 years ago, this was very new. At this point, it's not so new anymore. It's been installed at a lot of sites, increasingly being used. And it's showing that it does have some longer period of, probably decade or 2 decades. We're not sure, to be honest with you, but that's what it suggests. We're on that order of magnitude. And that's something we have to plan for, is monitoring that and polishing it up with a little bit, or adding some extra carbon as needed in the future. But the idea to that is that it buys us time, because in addition to this carbon and this treatment technology, there's a lot of other technologies being evaluated right now, including some being evaluated right here at MIT. And so, the mindset we have right now is this buys us time. It contains the contaminants at the site while other technologies are evaluated. Heck, Brian's talking about one right now that's taking carbon and tweaking it a little bit to make it a little bit bigger grain size so it doesn't move quite as far, and maybe mixing in some resin. That's the dual sorb that he's talking about. That wasn't around, as he said, a few years ago. So there's a lot of those things coming onto the market right now. The one we chose is probably one of the oldest. It's well known. The DEP, who's here in the audience right now, was able to evaluate whatever data is available out there, and they were comfortable enough with it to allow us to move forward with it and support it, I should say. So I hope that answers your question. There's uncertainty in everything. There's uncertainty with this.
I've got a little bit of follow-up on your question. So you'd asked about the Mar wells. In looking at where the PRB is being placed, and the concentrations that we have already moved beyond that down gradient. It's a very high concentration coming from the fire training area. The travel time for groundwater from the fire training area to the Mar wells could be as much as 20 years. So what happens at the property line of the fire training area doesn't have any effect at the Mar wells and the amount of carbon that's used until all of that PFAS flushes out over what might be a 20-year period at best, and is likely to be much longer because these contaminants don't necessarily flow at the rate of groundwater. They tend to leave a snail's trail, if you will, of compounds in the ground that flush out much slower. So we could be looking at many decades before there's any reduction in the amount of carbon that Hans might need at the Mar wells. It would happen sooner at the Mary Dunn wells. But wanted to point that out.
Thank you, Liz Argo from Yarmouth. I kind of have a follow-up to that. Does this mean that that area where we have the carbon that has now paired up or matched with the PFAS, do we have brownfields that we are essentially creating that we need to protect from somebody doing something in the future that could be dangerous to them?
That's a tough one. Dave, you can handle that one.
It's something that we would be looking at in the future as to whether any type of deed restriction might be required. But as long as the permeable reactor barrier is needed to mitigate flow from the site, we'll be monitoring. So there'll be a presence, there'll be monitoring activities, observations. So it's not like this is something that we throw on the ground, we walk away, and people forget about. It's something that there's an active component to it.
But there is no plan to remove it. Once it's there, it's 80 feet down. Can't hear you. but there is no plan to remove it once it's there. Once it's there, it's 80 feet down. We're not going to dig it out. Okay.
Yeah, that was my question. You talked about, if you're getting more through there, you need to add more carbon. You talked about it being a slurry. So there's no way to get this slurry out. But you said, how many feet is it down?
It varies, but it's on oh, sorry about that. It varies, but on average, it's 60 to 80 feet. And so it's down there. We're not going to be able to dig it out per se. Plus, it spreads out. So you end up with a carbon zone in the subsurface.
Are you saying that this carbon holds on to it forever? It's not going to then in some future time release from the carbon? The carbon will, this slurry just stays there?
It
And
would be very slow because of you're looking at groundwater flow rate is much less than, say, the flow rate that goes through Hans's canisters for his treatment system. So it's a much slower process, and the concept and the design is that yes, it stays there and holds on to that carbon, that PFAS, for the duration. And of course, as I said earlier, we're also looking at, while this is holding on to it and buying its time, because if we can hold it at the site, then concentrations at the well should drop because we're cutting off the source of the PFAS, right? So that's good in that it makes treatment easier, less expensive because we reduce the concentrations, therefore you're using less carbon at the wellhead treatment. So that means your carbon changeouts should be less frequent, so you use less carbon. So that's all good stuff. But while all that's happening there are still other methods being developed, and if there's another method that comes in that makes sense, then that's something that the county would probably look at. It would make sense to do that.
Hi, I'm Tom Cambereri. I've been working with a great group of people here in Hyannis and under a TAG grant that's looking at following the cleanup activities of the airport, and it's called the Hyannis PFAS Community Working Group. And here with a number of members here, we put together a pamphlet. We've been talking in front of town council, boards of selectmen, and other groups. And we have been quite active. We used community level data from the Mill Creek Marsh to highlight the fact that an area downgrading to the airport had not been looked at previously, and so I think we take some credit for moving the airport to look at that. So thank you for doing that. We appreciate that very much. A little disappointed we didn't get that sample near the Mar well results, because those were the really high results there of really high PFAS levels. And if it hadn't been sampled, I guess I was thinking our group would be pleased to go out and sample it. Perhaps the county could provide us with a free laboratory access for PFAS analysis for that community level concern. It was interesting, the results that you showed there, where you found your signature 6,2-fluorotelmer in high levels. You also found some pretty high levels of PFAS 6, so that they both occurred together. And when when we go back and we look at the graph of the performance of the cap, which was great to see the 6,2-fluorotelmer really responding to the cap and going down. But the thing is that we're concerned about the PFAS 6. The PFAS 6s are the regulated compounds. The PFAS 6 are those compounds that we're concerned about. So I have asked the airport and also through DEP that I wish these graphs would just show the PFAS 6 compound, because if you do, and you do that at appropriate scale, you'll find that, oh, that PFAS 6 compound also fluctuates as a result of water table fluctuations. So I'm also looking forward to we are looking forward to the results of the upgradient well. We hope that casts some light on this and helps us both resolve this issue. The other thing that the PFAS Hyannis PFAS Community Working Group is concerned about are the unidentified plumes. One of the unidentified plumes that the county found along the old Mary Dunn Airport Way road, I forget what it's called, but it had really high concentrations of the 6,2-fluorotelomere, the airport signature. And we're concerned that these unidentified plumes, that there's no investigation of those areas, upgrading of within the airport. And, I guess that's problematic because a lot of that is, within the airport runway and might be difficult to do, but there must be some ways to do that. So we remain concerned. I'm not, in looking at the groundwater models, I don't think we could just cast this off and say it's the wastewater treatment plant throwing off a plume up to the north, to that far north. So these unidentified plumes are still a concern to us. And now the county, I have a couple things with you. One is you're calling it the Municipal Training Facility. And that is actually the Barnstable County Fire Training Academy. It had been from the beginning. It seems to me that calling it the Municipal Training Facility is kind of trying to divert attention back to the fact that it was the municipal fire departments who are at fault, not the county. The other thing that I take that I think needs some looking at is the cease of the time of the use of AFFF at the site in 2009. There is evidence showing that there was infrastructure, there was use of these compounds, and even finding them in 2015. So, the concentrations under the hotspot. If you think about it, if activity stopped in 2009, that these really high concentrations just languished under the hotspot for that long. I'm not sure about that. And then lastly, I think also for the town, I think this is a big issue. And when I go to the town website and look for information on PFAS, I find many links to DEP, to the county, to something else. But I think there's been a lot of information that's been generated here locally, and I would like to see that. I think the community would like to see that beefed up. I think. It would be a reasonable thing to do. So those are just some of my comments. I'm not expecting any answers. I know it's been a long evening, and I would want to thank you, Jim, for getting the grant, putting it together. I think it was a great way to end your activities, and and I like the. You're introducing the issue about the secondary sources and the big picture that we have in front of us here in Hyannis. Thank you.
Tom, can I just ask you a question? Do you mind?
Who's that?
Can you hear me?
Yes.
Okay, great. No, I just wanted to comment. If you've got data that suggests that PFAS was used through 2015, I'd love to see it. So you said there's evidence. If you please share it with us. We want to see all the evidence we can get, all the data.
I have it.
Please send it. You know my email address. Please send it. Thank you.
Thank you, Tom. I have one more question that I'll read here. It goes back to the beginning of the presentation when I was talking about the water supplies, and it's a pretty straightforward answer, so I'll go ahead and do that. How is PFAS removed from the raw water? So the simple answer to that is it's a carbon filtration system. And as Dan said earlier today, it's somewhat like fish tank technology. It's the same kind of system that you might use in a fish tank to remove organic contaminants. Carbon filtration is a tried and true method for many contaminants, and it's been adapted for PFAS treatment. Now, that's a way oversimplification because there's a whole lot that Hans does in that treatment plant to get the water to the state that it is when it's distributed, and high quality water. But it is filtered and removed by carbon filtration. That carbon absorbs the PFAS and that carbon is periodically changed out and shipped out for treatment to remove the PFAS at a facility far from here, where the PFAS is concentrated, and then that carbon can be reused, and the PFAS is properly disposed at that location. I want to have one more question in the back.
It's really not a question, it's a comment. Good evening, and thank you for this wonderful opportunity to meet with so many people, knowledgeable people about PFAS. My name is Cheryl Osimo. I'm the Cape Cod Coordinator for Silent Spring Institute, and I just wanted to take this opportunity to thank the town of Barnstable for their many years of support with all of the research that we've done here. It's been a pleasure working with Dan Santos, Mark Els, Hans Kaiser, a great team. Thank you very much.
So, seeing no other questions, and I think we've addressed in either directly or indirectly all the cards I have up here. I don't know if you want to say anything else to close out the meeting, Dan, but I'll turn it over to you.
And I'll just echo what Cheryl said about thanking the town, and there was part of the question here about the town showing leadership, and we are grateful to everyone in the town who supported our health study. I think it was an important step for the town to step up and be part of this health study, and I know there's still a lot that we don't know about health effects, but we're really grateful for all the support that we've received from the town for the health study, but also for many years in our research.
Okay, thanks. Well, I'd be remiss if I didn't, and John mentioned it, mention that the Department of Environmental Protection representatives are here. Angela Gallagher and Navpreet Berlowski. They are the people that are managing the sites here and making sure that everything that we're all doing is in accordance with the mass contingency plan. So welcome to them. If you have any questions for them, you could probably catch up with them later. I want to thank you all for coming. And just mention, I've heard it a couple of times, Tom mentioned it, we are in the process with Kelly to rebuild our Department of Public Works website to be a real high-quality website, and it's almost ready for launch. So all the information or input we can get as to what things the public would like to see on there, I'm sure she's writing those things down. We want to have it to be the one place where you can get all the information on this issue and others regarding public works, and particularly the Comprehensive Wastewater Management Plan. And furthermore, I would encourage you to continue to reach out to us through emailing, calling, stopping in, talking to your elected officials. I know there are Yarmouth elected officials here tonight, including town councilors from Barnstable, and let them know what's important to you, and we will keep tweaking these investigations and tweaking these programs to make sure that not only are we meeting the standards that the state sets, but that we're meeting the standards that the community wants to set. So with that, thanks to all the presenters, and thanks to all of you for coming out for kind of a late night, and we hope to see you again soon. Thank you.